Hi, this is Alex from devstories.eu. Async IO, episode 13 of 20. Building a highly concurrent TCP server in Python usually means wrestling with thread pools or complex event loop configurations. You can actually handle thousands of connections in fewer than 10 lines of code. That is exactly what we are covering today by building async servers with async IO streams. The foundation of a network server in async IO is a function called start_server. You pass it three things: a callback function, an IP address, and a port. When you await start_server, it binds to that address and begins listening for incoming TCP connections on the network interface you specified. Developers often assume they need to manually intercept these incoming connections and write boilerplate code to dispatch them to worker threads or custom background tasks. That is completely unnecessary. The framework handles the concurrency for you. Every single time a new client connects to your port, start_server automatically spawns a brand new async IO task dedicated entirely to that specific client. Think about building a simple chat room server. When your first user connects, start_server triggers your callback function and hands it two objects, a stream reader and a stream writer. If 50 more users connect simultaneously, 50 separate tasks instantly spin up to run that exact same callback function. Each task receives its own isolated reader and writer pair. Inside your callback function, you write the logic as if you are only talking to one person at a time. You use the reader object to listen for incoming messages. You await a read method on the reader, specifying a maximum number of bytes you want to accept, like 100 bytes. The reader gives you raw bytes from the network, which you decode into a standard text string. To reply to the client, you reverse the process. You encode your response string back into bytes and pass it directly to the writer. Here's the key insight. Passing data to the writer is not an asynchronous operation, but ensuring that data actually leaves the physical machine is. After giving data to the writer, you must await the writer's drain method. Draining pauses your current client task until the operating system's network buffer has enough free space to push the bytes out over the wire. This step is critical because it prevents your server from consuming all available memory if a client has a slow network connection. When the conversation finishes or if the client disconnects, you tell the writer to close. You then await the writer's wait_closed method to ensure all final bytes are transmitted and the underlying socket shuts down cleanly. Back in your main setup function, start_server returned a server object. By default, the server stops listening if the main async IO task reaches the end of its instructions. To keep your chat room open indefinitely, you take that server object and await its served forever method. This locks the main async IO task into an infinite loop, quietly accepting new connections and spawning new client tasks in the background. The real power of this design is that it abstracts away the networking complexity. You write straightforward sequential code for a single isolated connection, and the event loop scales it across concurrent tasks automatically. If you want to help support the show, you can search for DevStories EU on Patreon. That's all for this one. Thanks for listening, and keep building.